in number 1A, we want to find the measure of or the length of the minor arc AB. The minor arc AB is the curve from A to B. That's the minor arc AB. So how do we find the minor arc AB? There's a formula for it. So the length of an arc can be obtained by, let's say, the measure of the angle, let's name it x, divided by 360 degrees. And then since arc is just part of the circumference, so x over 360 times the circumference 2 pi r. Right? Now, we need to know what is x and we need to know what is r. So we look at the diagram and we have to find this information. R is the radius. The radius is from O to A or O to B. O to B, the measure is 8. So that means R is equal to 8. Now, the x is the angle formed through the segment OA and OB. So that's the angle that we need for the arc AB. So x is equal to 85. So that means if we are using this formula, we just put these numbers. So x is 85 degrees and r is equal to 8. So the solution will continue as x is 85 over 360 times 2 pi times the radius 8. And then you can just use your calculator to simplify this, or you can solve it manually. Now it says in the given that you can use pi, so although the symbol is different, this is pi. Pi is 3.14. That means you replace the pi by 3.14. Can you do that in your calculator? Do you think you can do that? So I'll be leaving this to you. So just place the 3.14 on the pi and then simplify the number. So 85 divided by 360 and then times 2 times 3.14 times 8. When you simplify this number, that will be the answer for letter A, which is the length of the minor arc AB. Okay? Is it clear? So I'll be leaving that to you. So when we simplify the number, the length of the minor arc AB is equal to 11.86 centimeters. Now the follow-up question is find the perimeter of the shaded region. Perimeter is just the sum of the line or the curve that encloses the shaded region. So that means we need to add the radius OB, the radius OA, and the arc AB. So that is simply 8 plus 8. So we have OB plus OA plus the arc AB, which is 11.86 centimeters. Okay? So this is 16 plus 11.86. This will give us 27.86 cm. That is the perimeter. Okay, is it clear? So the perimeter is the measure of the sides and the arc enclosing the shaded region. So it's a radius OA, OB plus the arc AB. Add all the numbers and then you will get the value for the perimeter. So the next thing that we need to do is to find the area of the shaded region. Okay, so formula is, so let's say x is the angle over 360 and then pi r squared, that is the area. So x is 85 divided by 360 times pi. The radius is 8 and then squared. Now we can use 3.14 for pi, so that is 3.14 and then 8 squared. Simplify this either manually or by using a calculator, and you will get the final answer. So this will be 47.45. This is an area, so the unit should be cm squared. Okay, so we know how to find the length of the minor arc, we know how to find the perimeter, and we know how to find the area of the shaded region. Now let's proceed with the next question. So same set of question, a different figure. So let's try this one. So it says we want to find the length of the major arc. So the major arc is the bigger arc. So if you look at the figure, this is the minor arc, while the other one is the major arc. Same formula will be used. So this will be x over 360 2 pi r. Every time you look for a measure of the arc, it should be 2 pi r. Area pi r squared. So if this is length, it's L. So x is 220, that is the angle given, and then over 360, then you have 2, pi is 3.14, and then the radius is 10. Simplify that number and you will get the final answer. If we simplify it, this is 38.38 and the units is cm. Now we will be doing the same thing. We have to find the perimeter, so that means we have the radius 10 plus another radius 10 plus the length of the major arc, which is 38.38. This will give us 58.38 and then cm. Did you get that? Now finally, we want to find the area. Same formula will be used. So area is equal to x over 360 and then pi radius squared. Same angle, 220 over 360. Pi is 3.14. The radius is 10, but you have to square the radius. Simplify this and you will get the final answer. So this will be 191.89. Area is cm squared. Okay, let's move to the next. Number 3. So calculate the area of the shaded region given that OA is equal to 20. So let's plot that. That's 20 for OA. And that's angle. So this means angle. AOB is equal to 100. So AOB is 100 degrees. Use pi equals 3.14 and express your answer correct to 2 decimal places. So what we want is the area of the shaded region. But take note that the shaded region is only this. If we analyze it, the shaded region is basically the area of the sector minus the area of the triangle. If you look at the figure, you will see a sector and a triangle. So first, we need to find what is the area of the sector. The area of the sector is x over 360 pi r squared. And then minus the area of the triangle. So remember, there's a special formula for the area of a triangle given two sides and an included angle. Now also take note that OB is also 20 because that is also the radius. So using the special formula for the area of a triangle, it's 1/2 the two sides, so 20 times 20, and then sine of the given angle, which is 100. So the next step that you need to do is to put the corresponding numbers on x and r. So the solution becomes x is 100 over 360 times pi is 3.14. The radius is 20, and then you have to square. Then minus it with the resulting value of 1/2 20 times 20 sine of 100. So the 1/2 20 times 20 times sine 100 is 196.96. So finally, we just have to subtract the 2, but you have to simplify this and then minus 196.96. So this will become 151.93. This is a shaded area, so the unit should be, are we using cm? The unit is cm, so we have cm squared. So we're done with number 3. Now the key idea is the shaded region can change. So depending on the figure, you have to identify whether you have to use area of the sector, area of the triangle, and other area of like figures like rectangle, square, and so on. So you have to identify the figures involved. Now let's go to conversions. So number 4 is about converting a degree measure to radians. So this will not be too difficult because all you have to do is to multiply the given measure by pi over 180. The pi over 180 will convert the 240 degrees into radians. Now, there are many ways to approach this. You can do it manually. You can do it through a calculator if you want. Okay, so just choose whichever is convenient to you. Suppose we use a calculator for this. What will be the simplest form of 240 and 180? What is 240 over 180? What did you get? So manually, this is 0, 0, 24 and 18, divisor is 6. This is 4, 18 by 6 is 3. The radian measure should be 4 pi over 3. So I can leave the measure as 4 pi over 3. And that's it. Okay, let's go to number 5. So number 5, convert 5 pi over 4 radians to degrees. So to convert, you copy the number and then multiply by the conversion factor, which is just the reverse of the one we used for number 4. So 180 over pi. Now simplifying this, pi will cancel with pi because that is just 1. Then 180, you can use 180 over 4, so that is 45. So this is basically 5 times 45. 5 times 45 is equal to 225 degrees. So the radian measure for the degree measure for 5 pi over 4 is 225 degrees. So key idea is you should know how to use the conversion factor. For number 4, you use pi over 180. For number 5, because you're converting radians to degrees, you have to use 180 over pi. Okay, moving on. So number 6, given that the figure is a right triangle, so take note, it's a right triangle, so one angle is 90 degrees. Calculate the area of the shaded region. Then express your answer correct to 2 decimal places. Let's create a copy of the triangle. So there's like a quarter of a circle because this is 90. And on top is 1. This is 1.5. And this is just 0. So we have 0.5. Now take note, the figure here is a quarter of a circle. So if this is 0.5, this is also 0.5. Now we're looking at two different figures. The one is a triangle and the one is a quarter of a circle. Now do not be confused. The side of the triangle here is 1.5. That's coming from 1 plus 0.5. The side of the triangle here is 2 coming from 1.5 and 0.5. It's a right triangle, so this must be 90. So in concept, if I want to find this shaded region, okay, if we analyze it, this shaded region is basically the area of the triangle minus the area of the quarter of a circle, right? So if we could find the measure for this, for the area of this, and the area of the quarter circle, and subtract them, then we're done, right? Now let's find the exact areas. For the triangle, we need to use 1/2 base times height. That's the area of the triangle. It's 1/2, base is 2, the height is 1.5. For the area of a quarter of a circle, that is basically 1/4 the area of a circle, which is pi r squared. So we have 1/4 pi, the radius is 0.5, so 0.5 squared. So all we have to do is to find these two numbers and then we should subtract them. So actually, on the first one, 2 will cancel with 2. So this is just 1.5. For the second, use 3.14 for pi. So it's 1/4, 3.14, and then 0.5 squared. Okay, so the second one will be 0.92. So we have equals 0.92. So final computation will be area of the triangle minus area of the quarter of a circle. That's 1.5. So we have 1.5 minus 0.92, and that is equal to
1.3.
It's no longer 1 point. 1.3. What's the next number to 3? No, 1.3. What's your answer? 1.3. So it's just 1.30. Okay, so this is the area, an area, so we use cm squared. Okay, so this is cm and then squared. So that's the end of the assessment number 2. So we answered all the items for assessment number 2. Okay, so do you get it? So this will be the content of the assessment, so I advise that you review this video in preparation for the test. Okay?